everybody. In this Desmos tutorial, I'm going to show you how to make an analog clock. This one is going to be split into two parts. First, the goal of the first part would be to get the outline and the tick marks in, and then in the second part, we're going to get all the numbers in. As for the numbers, you can choose to go Roman numerals, Arabic numbers, or whichever one you choose. So we're going to get started with the outline. This one we're going to set around the origin, of course. Start with the circle. And this 36 is 6 squared, by the way. It's the radius of 6. And I'm going to make one a little bit bigger than this. These numbers are not predetermined. They're arbitrary, and we can adjust them as we see necessary. In fact, I'm going to go ahead and define two constants right out the gates here. So R1 is going to be for this inner ring here. And then R2 is going to be for this outer ring here. So now, if we decide this is going to be bigger, it makes it a lot easier to adjust. Something they can also do is make this in relation to R1, so that when you scale the inner radius, the outer radius just moves with it. You don't need to worry about adjusting two numbers at once. Your choice on how you want to design it. I want to leave both options out, available at least. And next we're going to fill the inside. So to do that, we're going to use inequalities. This is going to be made of four inequalities. One to get the region between two top hemispheres, and that's going to be a square root of R1 squared minus x squared is less than or equal to y, and that is less than or equal to square root of R2 squared minus x squared. If you got the two flipped, you would reverse the inequality symbols. Let's change this color a little bit. Now we're going to do the same thing down below, except instead of the top half, we want the bottom half, and we don't want the less than or equal to anymore. So this is what I was talking about with reversing the inequality symbol. Reason is that this piece here, which is this line that I'm pointing at, the bottom half of the inner circle. This is situated on top of the bottom half of the outer circle. If you accidentally made a mistake, like I just did, Control Z will bring it right back. Now we need to get this left piece here, and we also need to get this right piece here. And in that case, this is the advantage with the defining constants rather than gates, is so that you don't have to keep remembering what numbers you picked at the start, and you also have that ease of adjustment. So this is going to be, I'm going to go the bottom half first. This is R2 squared minus x squared. I'm going to bind that with the top half here. Right, so actually, in fact, we might not even need to do this. Instead, we can even say x squared is less or equal to R2 squared. So it's this exact same graph, but now with the inequality distributions filled in. So what you can do at this point is you can now define your inequalities. You can now define your intervals in here. So this would be, in this case, from minus R2 to minus R1. And we can also get R1 is greater than or equal to x. We could simplify this further because the domain of this graph does not exceed minus R2. We don't even need to explicitly mention that. We can just do this, and it'll still get it. If that didn't make sense to you, let me know in the comments below, and I can help clarify that further on why this works. And while we're at it, and so that we can wrap up the top half here, I'm just going to make them all one color. It doesn't have to be green, of course. Great. Now, next piece here is to do the ticks. So this would be numbers that you see labeled 12 right the way down around and to 11 here. And we don't need to draw 12. We don't need to make 12 numbers literally, or 12 ticks literally. We can save ourselves some effort here by taking advantage of the fact that if you draw one line just straight across a circle, we would just impose two inequalities on one line, and that would save us some work. This would be a good time to put these guys in a folder. Let's make another folder. This would be for the outer rim. We can call it a clock rim. Alright. In our next folder, we can call it clock face. And now we can start drawing our ticks. For this vertical line here, it would just be x equals 0. And let's define it from this point here. This looks like 5.5 down to minus 5.5. Sounds like a great time to define another constant, R3. So R3 is going to be, it's going to be two constants. R3 is going to be this, would be the outer boundary of our clock face ticks, and R4 would describe the inner bound, describe the inner ring here. So in this case, we'll be looking at, let's do 5.5 and see how that goes. And for other constant, let's do R3 minus 0.5, and we'll see how that goes. So in this case, we would be looking at, because it's a vertical line, we would have R3 being the bigger value here. Use Y, by the way, because we're going down along the Y-axis, all the Y values here. If you go through all the X values, you're still gonna get your line. It's not gonna clean it up, or it's not going to change anything for you, I should say. If you want to make your format consistent, you may choose to have your R3 be the smaller value and your R4 be the larger value. And what that would mean is you would need to switch your inequalities, because now your R3 is less than your R4. As you can see, you can see a check mark being drawn. We'll do the same thing here. And we'll have minus R3. Well, minus R3 is now the larger value on the bottom. And minus R4 is now the smaller value. These error messages are good to have. It did not like the fact that subscripts may only contain letters and digits. A space is not allowed. This is pickier than I imagined it to be. That's all good. If you run into issues, hover over the exclamation mark and see what I was telling you about. Alright, so one line so just in one equation we drew two of our ticks, and we would go through a similar process to draw several other ones. Let's do the easy ones first. Straight down and straight across. So straight across would just simply be y equals 0, and it would be a similar kind of inequality, but instead of using y, you would now be using x. Alright. Our next equation is going to be, or our next ticks are, we're going to go for the lines that are, we're going to go for diagonal ones. The easiest one being the one that's at a direct 45-degree angle. Talk about y equals x. and y equals minus x. Let's worry about one of them first. Color orange, so you can see that this is the one that we're working on. And so this one, question is, how do we know what? So if you were to rotate this tick here 45 degrees, how do you know what that point is? And you could choose to use either the y constraint or the x constraint. It doesn't matter. Well, what it will matter is which function you use. So if you're using x, I'll show you both ways, depending on which one you prefer. If you're using x and you want to know what this point is, whatever that's going to be, it's going to be the radius, or the we're going to take one radius, or radii rather. It's going to be r3 times the cosine of 45 degrees, which in this case, if we make half a revolution, that's pi. 1/4 revolution is pi over 2, which means this 45 degree angle must be pi over 4. Do the same thing, r4 times cosine of pi over 4. So if you were to use use y as your constraint instead of x, you would switch it out for a sine instead of a cosine. Because the sine talks about the opposite end, or in the context of a graph, it's talking about the vertical line or the y-axis. So we switch this over to sine instead of cosine. You can see here that we're getting the same results. I'll show you both just so you have both of them in front of you and you can just pick which one you like. Let's do. We're going to the minus side now, so it's be minus the cosine, or minus r3 times the cosine of pi over 4 is greater than or equal to x, and that's greater than or equal to minus r4 times cosine of pi over 4. The math for this graph here would be very similar. So instead, so you just need to make a few adjustments for it to work. So first, obviously, it's going to be y equals minus x, and then we would have r3 times the sine of this less than. So this won't be pi over 4 anymore. This will instead be pi over 2 plus pi over 4, which is 3 pi over 4. If you want to see video explaining where these values come from, you can. The high level is, well, the short explanation is that you assume you treat the circle like it has a radius of 1. And you measure how much of the circumference have you gone around. Okay. So this would be r3 times the sine. That would give us this value here. R4 would give us that value up here. Alright. So minus R3 would give us this value down here. So this should actually be flipped. Right, we have 2, 4, 6, 8 done. Just 4 more. So this time we're going to be going. I believe if we capture the ones in between, we'll be good to go. Trying to think. Did we pick the right angle? Alright, a few things I do want to correct for. So first thing, there's no tick at a 45-degree mark. As we are incrementing in 30-degree marks. So this would be where the 1 would go, and if we go another 30 degrees, that's where the 2 would go. And when we hit it, the straight horizontal one, that would be that'd be where the 3 would go. Also, when you apply trig functions, the angle starts from this positive horizontal side, and starts counting upwards in a counterclockwise direction. Do not do what I did before, which is start from the positive vertical end and go in a clockwise direction. You will see things that would start confusing. That would start confusing you. So I do want to at least get those two things out of the way. So this is what I am correcting for right here. For a 60-degree angle, it's got a square root of 3 slope here, referencing the 30, 60, 90 triangle, with ratios being either square root of 3 or 1 over 3 here, and that would get you. So this inequality would get you this line here. So we're just going to fix this line here, which is going to be sometimes it's easier to wipe it out and recalculate from there. So that would be R3 times the cosine of pi over 6. So that would get you 30 degrees off the ground here, like off of this line here. And so if we make that less than or equal to x, and finally the other side. Okay, this side's going to be interesting because now when we circle back, we don't have the luxury of just simply flipping numbers around and flipping inequalities around. We actually need to figure out what this angle is. So this would be pi radians around plus another 30, so that is, so we're adding another 1/6 to it, so you're looking at 7 pi over 6 if I am not mistaken. So we minus R3, 7 pi over 6. That's not good. So this R3 needs to be at what needs to be over here, which means this has to be a larger value, and that's what we're trying to resolve here. If we go pi times around, so we did pi plus pi over 6, do we get a similar result? Yes, we do. Turns out I may be about to be making this way more complicated than I really needed to be. If you just sat through this just to find out that yes, you can't just flip these guys around. Seriously, apologize for that. It ended up being a much simpler solution. I will color code these just so you can at least see what the results look like over there. We would of course be doing something similar for this segment here and this segment down here. Because I'm going to do a dangerous thing of duplicating it, and first thing we would do would be to make both of them negative. And that solves all of our problems there. Thank you all for watching very much. If you have any questions, I know it's been a long video. I'm estimating about 30 minutes long at this point, isn't it? So if you have any questions, confusions, by all means, drop them in the comments below, and I'll get back to you as soon as I can. Otherwise, the next part we're going to be putting in some numbers. It's probably going to take longer than 30 minutes. It's if I did them all on recording. So we'll see how that piece goes. So until next time, take care.